Natural systems can throw us a lot of curveballs. A lot of things can happen that we're not really ready for.
This restless Yellowstone caldera is truly living, breathing. Every once in a while, it burps.
Shocking news has emerged from Yellowstone Park as it unexpectedly closed its doors. The reason behind this closure is a groundbreaking revelation announced by the NASA chief. A never-before-seen phenomenon has suddenly emerged, leaving scientists and onlookers astonished. This incredible occurrence has transformed the park's peaceful atmosphere into a blazing inferno. Join us in today's video as we explore this mesmerizing spectacle that has become the focal point of attention at Yellowstone National Park. Yellowstone is truly a remarkable destination that never fails to amaze. Its abundance of awe-inspiring features is simply breathtaking. Among the must-see attractions in Yellowstone, the vibrant Grand Prismatic Spring in the Midway Geyser Basin takes the spotlight. Not only is it the largest hot spring in the United States and the third largest globally, but it also stands as one of the most exceptional natural wonders on Earth. This iconic landmark of Yellowstone is instantly recognizable and has been captured in countless photographs. However, it's only when you stand beside it that you truly grasp its immense size. Stretching larger than a football field and deeper than a 10-story building, the Grand Prismatic is an impressive sight. What sets the Grand Prismatic Spring apart is its captivating displays of colors. This is no ordinary hot spring. The combination of bacteria and minerals present in the water creates a mesmerizing show of vivid hues that will leave you in awe. Along the edges, microbial mats formed by bacteria flourish in various shades, transitioning from green to red as the temperature and season change. In the center, the water's natural color emerges as a deep striking blue. Each minute, an astounding 560 gallons of water flow from the spring, maintaining a comfortably hot temperature of 160 degrees Fahrenheit. And have you heard about Yellowstone's boiling river? The boiling river was a 6-foot wide stream of hot water pouring over a travertine ledge into the Gardner River. Visitors had ingeniously arranged rocks to create a designated soaking area where the 140-degree water mixes with the cold river. It was the epitome of a quintessential hot spring swimming experience unique to Yellowstone. However, for the past 3 years, this coveted spot has remained inaccessible to eager visitors. Its closure began in 2020 amid the global COVID-19 pandemic, depriving enthusiasts of its soothing waters. But fate dealt an even more devastating blow to the boiling river when the forces of Mother Nature wreaked havoc in 2022. Historic flooding ravaged the area, obliterating the very existence of the beloved destination. All 5 entrances to the park had to be closed, a rare occurrence that hadn't happened since the devastating wildfires of 1988. The National Park Service faced the arduous task of ensuring the safe evacuation of visitors, particularly those in the northern region which bore the brunt of the disaster. Cam Sholly, the park's superintendent, expressed a bleak outlook, stating that the closure of the northern loop would likely be necessary for an extended period. Aerial footage revealed the extent of the destruction, with sections of the road between Gardner and Mammoth Hot Springs washed away by the raging floodwaters of the Gardner River. The town of Gardner itself, home to many park staff, was cut off from road access, exacerbating the challenges faced by residents. The wrath of nature did not stop at roads and bridges. Mudslides and rockfalls buried other thoroughfares, compounding the transportation woes. Power outages plagued various parts of the 2.2 million acre park, adding to the already dire circumstances. The Yellowstone River reached a record-breaking level of 13.8 feet, surpassing the previous record set over a century ago in 1918 when it stood at 11.5 feet. The floods were a result of an extraordinary heat wave that had preceded the event, causing an abnormally rapid snowmelt. If it weren't for the substantial amount of snowfall, meteorologists from the National Weather Service in Billings, Montana, claimed they would not have witnessed such a catastrophic scenario. Fortunately, in the days following the calamity, the rain subsided, and cooler temperatures slowed down the snowmelt. Aside from the floods, Yellowstone offers more than just geysers and wildlife. Beneath the surface lies a remarkable geological phenomenon. You see, Yellowstone sits atop a unique and active hotspot, a molten zone in the Earth's mantle. This hotspot, unlike the usual tourist hotspots, melts the rock above it, creating a massive plume of magma eager to reach the surface. It's the stuff that volcanoes are made of. What's fascinating is that this hotspot remains stationary while the North American tectonic plate slowly drifts over it at a leisurely pace of about 1 inch per year. As the plate moves, the hotspot leaves a trail of volcanic features in its wake, calderas, lava flows, and geysers, as if it were leaving behind a volcanic breadcrumb trail. But this hotspot isn't just known for grand eruptions. It has quietly produced basaltic and rhyolitic lava flows over time, occasionally punctuated by explosive rhyolitic eruptions. It has also been responsible for 3 significant caldera-forming eruptions at Yellowstone in the past 2.1 million years, eruptions so colossal that they left massive depressions in the Earth's crust. Although the last major caldera-forming eruption occurred over 600,000 years ago, the hotspot hasn't been idle. It has continued to generate around 80 mostly non-explosive eruptions since then, with the most recent one occurring a mere 70,000 years ago. Even without a dramatic explosion, the hotspot's impact on the Yellowstone landscape is unmistakable. And now we come to the most formidable type of eruption, the one that has everyone concerned, a caldera-forming eruption. These events occur when an enormous amount of magma is catastrophically released from the chamber beneath the caldera. And when we say catastrophic, we mean it. These eruptions can unleash pyroclastic flows, deadly clouds of scorching gas and ash that obliterate everything in their path. But that's not all. They also eject vast quantities of ash and pumice, affecting a wide area and disrupting climate, agriculture, transportation, and even health. The most recent caldera-forming eruption took place 631,000 years ago, resulting in the formation of the Yellowstone caldera. Recently, the NASA chief issued a warning, emphasizing that despite technological advancements, we cannot accurately predict when or how such an eruption will occur. Therefore, it is crucial to stay prepared and well informed about the potential risks and appropriate measures to take in the event of a volcanic emergency. Speaking of unpredictability, something extraordinary unfolded in Teton National Park recently, sending chills down the spines of park authorities, including NASA. Suddenly, a colossal crack emerged, spanning a staggering 100 feet wide. Just imagine the magnitude of such a phenomenon. The sudden appearance of this massive crack triggered swift action from park authorities and NASA, prompting the closure of a significant portion of the park. Their immediate focus was to conduct urgent investigations, aiming to unravel the mystery behind this awe-inspiring occurrence and comprehend its implications for the surrounding landscape. However, several key factors contribute to the uniqueness of the Teton Range. Firstly, it possesses tough, durable rocks at its core, along with vertical uplift. While other mountains in Wyoming may share these attributes, the Teton Range stands out because it is relatively young, having formed less than 10 million years ago, and has managed to resist significant erosion. What truly distinguishes the Tetons, however, is the exceptional hardness and resilience of its rocks, making them highly resistant to mechanical disintegration caused by temperature changes, ice, and water. These rocks endure in the cold climate, where chemical decay is minimal, and their lack of weak layers prevents collapse under their own weight. Yet even the toughest rocks have their limits. Over time, temperature fluctuations cause contraction and expansion, generating stress and strain that lead to the formation of cracks. One notable crack gained attention in 2018, highlighting that even the formidable rocks of the Tetons succumb to nature's forces. Water sweeping into these cracks freezes and expands, exerting immense pressure that gradually dislodges slabs of rock from the mountain walls in a process known as frost wedging. The fallen rock slabs can plummet and shatter as they tumble down the mountainsides, creating talus piles in the valley below. If the rock debris mixes with snow or becomes saturated with water, it can flow slowly, resembling a glacier. Snow avalanches also contribute to the movement of loose rocks and debris, leaving scars on the slopes and exposing new surfaces to water and frost erosion. The diligent efforts of experts have been focused on studying the expanding cracks in rocks, closely monitoring them for any signs of movement. This research is particularly crucial due to the captivating phenomena taking place in Yellowstone National Park, recharging. Recharging refers to the process of the magma chambers beneath the Earth's crust being filled with molten rock, creating a simmering cauldron of fiery power. It's as if the volcano is inhaling deeply, preparing for a significant event. When these magma chambers reach their brimming point, the stage is set for a potential eruption, whether it occurs in a few months or thousands of years from now. During an eruption, the ruptured chambers release an astonishing volume of magma, forcefully propelling it into the atmosphere. We're talking about up to 240 cubic miles of explosive volcanic rock called rhyolite. It's important to note that rhyolite is no ordinary rock. Its immense power allows it to easily break through the Earth's crust, announcing its destructive presence to the world. The volcanic rock rhyolite holds the key to Yellowstone's immense power, capable of reshaping the landscape in awe-inspiring and sometimes devastating ways. Researchers have been diligently studying the Yellowstone area with a particular focus on the magma plume beneath the surface, which heats the rhyolite from below. Their mission is to understand the annual rate at which magma is replenished within the volcano, as this knowledge is crucial in unraveling the volcanic mystery. To aid in their investigation, scientists devised an ingenious method. Stable radioactive isotopes called deuterium were injected into several hot springs within Yellowstone National Park. This unconventional experiment, approved by park officials and NASA, poses no harm to the environment. These hot springs are intricately connected to a network of hydrothermal vents forming a vital part of the Yellowstone volcanic system. By measuring the temperature and tracking the time it takes for the deuterium to return to its normal background radiation levels, researchers could calculate the amount of water and heat flowing out of the springs. Surprisingly, previous studies had underestimated the magnitude of water flow and heat release from these springs. The abundance of water and heat indicates that the supposedly dormant volcano may not be as inactive as previously believed. Scientists are now warning that it is only a matter of time until this massive supervolcano awakens and unleashes a deadly eruption.